Yes, welcome. So today we're going to discuss about the velocity and acceleration analysis of mechanisms. So in the earlier we've been discussed about the velocity and acceleration analysis of mechanism by using a graphical representation or what we call it as a graphical method. So here we in this velocity and acceleration analysis of mechanisms we're going to discuss about and with an analytical method. So majorly what is the major difference between the graphical representation and analytical representation is so where we can able to identify the values is based on the graphical representation means we need to construct the graphical graphical representation. Here analysis we're going to identify the values by calculating by using the formulas. So in the graphical, so we're going to use the with the diagram and we're going to identify the values means based on the measurement of values. So then we're going to convert that into the scale and we're going to identify the values. So, so here also same. First, mainly we need to focus on velocity and acceleration and analysis of mechanisms. So, based on these conditions, we're going to identify the or we're going to analyze the mechanisms for the given different conditions. So, mainly in this video, we're going to discuss about the introduction to the velocity and acceleration analysis of a mechanism. So, that is according to the syllabus, it's in a model number 3. So, in this video, we're going to be discussing about the introduction. So coming to the introduction, so a mechanism is used to produce the mechanical transformations into a machine. See, whenever to manufacture any component, we require one machine. So how the machine works? So machine will be having a different number of mechanisms put together. It will form as one complete machine. So when coming to the how the mechanism will be formed is nothing but when the each mechanism, so the different motions will be formed as one complete mechanism, and different mechanisms put together what we call it as one complete machine. So similarly, each link will be having a connectivity, or each link will be having a relative motion one to the other. So then only any motions can be transmitted from one form to other form is with the help of the motions only. So how the motions will be generated? So the motions will be generated with the help of the links. So here all the mechanical parts in the inside the machine will be interlinked or what we call as interconnected. So all these mechanism machine parts will be interconnected. Then only we can able to form as one complete machine. So here a mechanism is used to produce a mechanical transformations in a machine. So these transformations could be either mainly it is used to convert from the one speed to the another speed. See mainly the speed variation. So how the speed variations is the speed is depends upon the required condition. What the conditions has been required for that we going to use the or we going to mention use the speed. So mainly it may be convert from one speed to the other speed. How we going to convert the speed? That is whether we need to increase the speed or decrease the speed. Also, we require some mechanisms. So mainly the transformation could be happen in the machines is it may be convert from one speed to the other speed. Next, it may convert one force to the other another force. It's mainly the force. So we normally we know that compressive force, tensile force, bending force, torsional force. So like this we have a different force, but at what the condition is required, so the mechanism has to convert that from one force to another force. For example, it is having a compressive force, but the required condition at that particular surface or required condition should be a compressive. So it going to convert that compressive force to the tensile force or other what the required condition or required force. It going to convert that force. So this is how it may be convert from one force to the other force. And coming to next, it may convert from one torque to the other torque. Yes, the torque is very important in any moving machines or any vehicles or any machines. So the torque is very important. Based on the torque only, the RPM or the speed of the machine or an engine can be identified. So even the torque from whether the torque has to be increased or whether the torque has to be decreased. So based on this, again, the mechanisms are it going to be converted from one form to the whether it might be the torque should be increased or whether the torque should be decreased. So next, it may convert force into torque. So sometimes it has to convert that whether a mechanism has to convert from force into torque or either it should be convert from torque into force. Next one is it may convert one angular motion to another angular motion. As I told earlier, so motions and mechanisms can able to transmit one form to another form in order to get an required output. So in that case, so the mechanisms have been used in order to convert from one angular motion to another angular motion. and it may convert angular motion to the linear motion, and it may convert from linear to the angular motion. So like this, the machines and the mechanisms, as I told in the earlier, so mainly it focuses on the output. So for that output, so all the parts will be inside the machines will be interlinked. So it can able to convert from one form to another form. Easily it can able to transmit the motions in order to get a proper output. For a good example of any mechanism inside the machine is nothing but a crank, connecting rod, and the piston mechanisms. So these are the very good examples for an machines and mechanisms. Very easily it can able to transmit the motion from one form to the other form. See, then coming to the this example, see now it is the diagram where you can able to see this is the piston rod and the crank mechanism. So where, so this is a piston, and this is a connecting rod, and this is a crank which has been connected, and we can able to see this is a pin where it has been connected, and the piston is moving in a linear motion. See now, when the piston starts moving in a linear motion, automatically the crank will starts rotating. So in between this piston and the crank, so we have a connecting rod. Because of that connecting rod, so here the crank starts rotating, automatically the linear motion will takes place. If the linear motion here takes place, automatically the rotation of the crank will takes place. Right? Means the rotation takes place at the crank, and the linear motion will be takes place at the piston. See, at a time, both the two motions will be taking place for a different output. So linear motion and a rotary motion. So here the piston will be moving in a linear motion, and the crank is rotating in a, it is in a rotational motion. So this is how the each motion which has been interlinked or interconnected in order to get a required output. So if the crank is turned, angular motion is converted into the linear of the piston, and the input torque is transformed into the output force of the piston. Where you can able to see this linear motion as we have been discussed. Okay, mainly these are all this motions is completely takes place inside the engine. As we know that inside an engine, so all the different mechanisms put together to form an one complete mechanism. So how one complete mechanism that has been used is, see this linear motion is now whenever the piston starts moving in a linear motion, automatically the crank will takes or the linear motion is converted to the rotational motion. See, without any extra equipment or without any other source, no, the linear motion has been converted to the rotational or rotary motion to rotate the crank, right? So, if the crank is turned, angular motion is converted into the linear motion of the piston, and the input torque is transformed into the force on the piston. So now, only the one input force and the output is two motions, right? See how we can able to identify is, now we have just applied a one input force and we are getting two motions at a time. So next, if the piston is forced to move the linear motion, this is converted to the rotary motion. Now the linear motion is converting to the rotary motion, and the force into the torque. Again, the piston is a sliding joint, and that is what we called as an prismatic in some fields of engineering such as robotic. So mainly this prismatic and revolute joints has been used in the robotic arms in order to move, like especially in the industries like pick and place the robots where we are going to use. So where the men's can means sorry, that is human beings were cannot able to use the means continuously cannot able to work. So at that conditions, so they going to use as in a robots, that is to pick and place continuously, it can able to work for a 24 hours without any break. So in that also the sliding joints like prismatic and revolute joints has been used in the especially in the pick and place robots. So next is about the pin joints, so that allow the rotation of one part of relative to the another. So these are all called mainly the revolute joints in the other areas of engineering. So these are all some of the how the motions has been converted from one form to another form in order to transmit the motions and in order to get a desired output. Yes, so this is about a brief introduction of the velocity and acceleration and analysis of mechanisms in the analytical method.